There are some certain characteristics of a designer. He might be a structural designer. Aspects has to be taken. While designing, you have to take all these consideration and start for design. So what are they? Let us look into this class. A structural designer may design concrete structure as well as a steel structure. But before designing, the concept which has to be done is analysis. After analysis, since you know analysis of determinate structure and indeterminate structure, after analyzing and before design, what are the things to be done? So it has to be taken care, and to design a structure in such a way that it fulfills the intended purpose. Soon after analysis, we cannot make design. Why? Because you have to know certain things before the design. Say for example, if you are designing a classroom, there will be guidelines. If you are constructing a college building, you will be having the norms. If it is coming under engineering college, AICTE and UGC will give norms. If you are constructing a medical college, then All India Medical Council will give you the dimensions. And if you are building any schools, then CBSE will give you the norms. An institution can be an engineering institution, medical, or a school. So according to the guideline of the respective board, they will be giving the minimum dimension. As per AICTE as concerned, they are giving 102 meter square as the classroom size. If you want to construct a college, and the college should have a minimum classroom size of 102 meter square. You cannot take the 102 meter square straight away. Why? Because it might be a technical drawing. Since you are a engineering student, you know you have a technical drawing, yes or no? So technical drawing class is different from the normal classroom. It needs 150 meter square of the area. So the AICTE will give you the minimum line, that is the border line. You have to take and decide the judicial dimension. And when you are constructing a residential house, the Bangalore Corporation limit, so they will be giving the guideline as minimum dimension for a hall, but it is not mandatory to have 160 alone. You might have increase, but it should not decrease. You should know what are the guidelines. Are you constructing a educational building? Are you constructing a residential building? A structure which is built for communication purpose, information purpose, that is IT and CSE. For all the things, the national guideline is available. You have to take the consideration. Soon after analysis, you will be getting shear force, bending moment, deflection and slope. These are the 4 answers which you will get. So after getting that, before design, these are the factors to be known here. First, you should know the guideline. What structure you are building. If you are building an atomic structure, so you have a specific guideline for atomic structures, purely how to construct that. India has given a code book called IS. For constructing a RCC and concrete structure, you have 4, 5, 6. Likewise, for building atomic structure, you have code book. So you should get the codal guideline. It should fulfill the intended purpose during its lifetime. First and foremost is safety. What are the things comes under safety is strength, stability and structural integrity. Let us discuss each and everything. That is first safety and serviceability. If you are a designer, safety is the primary criteria. What happens? You will include more material, and say for example, if you need 300 by 300 mm square of a column cross section, that is 1 feet by 1 feet. If that is the case, you can construct the same building for wind resistant structure. Then what happens? Your cross section of the column increases, and due to the wind load, you will be having the lateral force. Then you will increase the cross section. After increasing cross section, what happens? Your material will become higher. So you have to spend more. Okay. But if you increase serviceability, what are the serviceability aspect is? Increasing the stiffness, durability, etc. If you are constructing a building in Bangalore, Then if you are constructing a building in seashore or Mangalore, so Mangalore is a place where you have more sea oriented area. What happens in those area? You will be having wind with dewness. So you will be having much more dew in the wind, and in that factor you will be having saltness. The salt content will be there in the air. Due to that, what happens? The structure will be having a white kind of a patches, that is called efflorescence. So you will be having a white kind of patches in your building where you could observe in sea oriented structure. Another thing, the cracks. A small kind of cracks will be there. Most of the cracks are only due to the serviceability aspect only. If you keep on increase safety and serviceability, what happens? You will be not ending up with an economical structure. If you are constructing a building with 15 lakh, if you blindly increase safety and serviceability, what happens? The cost of the construction will become 30 lakhs. So you will be including 10 lakhs for improvement of safety and serviceability. And next aspect is aesthetically pleasing. Nowadays, they will be spending around one third of the cost for aesthetic purpose. It might be interior decoration. Now, whatever the residential building is built, you have the interior facility, yes or no? Definitely, they will be having false ceiling. They will be having interior kitchens which are designed. So, the kitchen will be designed with wardrobes, and all the interior cost will be having one third of the construction cost. Only the structural will be having a different cost, but if you need elevation is a different part. They will be having panels in the elevation, and interior decoration. What happens? You are planning for 20 lakh, 10 lakh will be there as the interior work. Aesthetic pleasing will be your another factor, and the structural designer has to take care about that. If you are drilling at each and every 0.5 meter distance, what happens? The structure gets disturbed. So it has to be also taken care. And final thing is environmental friendly. If you have an option, that is fly ash bricks is available for 7 rupees, red bricks is available for 6 rupees, and hollow block brick is available for 10 rupees. As a structural designer, which will be your option? You have three options. Eventually, everybody will end up in the red bricks. Why? Because the cost is 1 rupee is lower. But when considering the environmental aspect, how the red bricks are manufactured, by using the clay, they will be taking the soil, that is red soil, they will be making it into a brick. While manufacturing a brick, you will be burning it to 1500 degrees, yes or no? So when heating that, the environment is also get disturbed. So if you are going for fly ash bricks, what happens? Fly ash is a waste material, yes or no? Fly ash is a byproduct. So by getting the byproduct, you are making a material. When constructing, a structural designer should also aspect that even though you might get 1 rupees lesser, you are not allowing the environment to get disturbed. So you should know that you can prefer that 1 rupees and you can spend that and you can reduce the environmental issues. Say for example, if you are constructing a structure in Delhi, the Delhi is a place where you have high amount of air pollution, yes or no? So frequently they will be having air pollution. So in those area you can prefer fly ash bricks. Where you have less air pollution, in those places you can go for red bricks. So it is a designer who decides the material. So you should choose your material according to your priority. If your place is having high amount of air pollution, you should not use the red bricks or other bricks. So these are the aim. Before designing, you should take all the aspects. So I have given an outline called safety, but what does safety mean? So you can take these 5 points. Write it down. Okay, the first point says that the possibility of collapse of a structure is partial or total. See, here you can have these two terms. What are they? Partial or total. Your structure might partially damage or totally damage. So these two contents comes under safety. We can see that number of housing units, that is public housing units, are being collapsed within 15 years or 20 years or like that. But structural designer will generally give safety for 60 years. The lifetime of a structure is for 60 years. So if a building is collapsing before 60 years, what happens? It is the responsibility of a soil, that is foundation engineer, or it is the responsibility of a structural engineer also. If you are constructing a building or if you are designing a building, you should make sure that you should give a guarantee for 60 years. 60 years for what? Safety. And if your building is going to get collapsed, it should not collapse immediately. It should be a progress or it should be a process. See, if a building is going to collapse, first level it has to attain cracks. Without a crack, a structural designer should not build a structure like that. It should not immediately collapse. See, an eggshell will get collapsed only after having the cracks. Yes or no? Soon if you have the crack, you know that it is going to collapse. So the building should be designed that the structure should get cracked and it should be collapsed after the second stage. Okay, first stage is called cracking, then next stage is plastic hinge. So the structure first level is cracking, but after that, imagine that your slab is being cracked now or it is going to fail now. What should happen is, first indication it should give the cracks, and next indication it should have excessive deflection. What do you mean by excessive deflection is, the code suggests that L by 300. L is the span, 300 is the constant. So if you have 10 meter of span, what is L by 300? 10,000 divided by 300 is what? 33.3, yes. So your structure will be having a deflection of 33 mm, that is 3 centimeter. So can you observe a 3 centimeter of deflection in a slab visibly? 3 centimeter is very low. It should go beyond that. So you will be having a visible deflection. Then at the next stage, you should find a plastic hinge. So what do you mean by plastic hinges? The visible steel should be there. Before collapsing, the concrete member should collapse first, not the steel. The concrete member has to fall. Then after that, you will be seeing the mesh of the steel. And after that, you will be having a plastic hinge, then only it should collapse. So this is the progress of the safety aspect of a designer. You should not build that immediately it is getting collapsed. So you will be looking in a cartoon. When a structure or building is collapsed, it will collapse immediately. Yes or no? A house will be there, or during a Tom and Jerry cartoon, you can see that immediately it gets collapsed and it gets vanished. It should not be like that. Why? Because these are the aspects, even for collapse, a designer has to take care, so that the people who are staying there will be getting enough attention, will be given in order to evacuate from the place. That is the part under partial and total collapse. The next thing is under frequent loads such as earthquake and extreme winds. So when you are designing for safety, you should check always what are the two forces, earthquake and wind. So you should check these two concepts when you are designing for safety. And also there might be accidental loads. It might be due to blast or it might be due to impact. If you are building your construction near the mining area or near the railway track, what happens whenever the track is being passed by a train? What happens? The vibration will transmit to the platform. Have you observed whenever you are standing in a platform, If a train is moving in a rail, you will be observing the vibration, yes or no? There will be slight vibrations, but even though due to vibration, the platform will not get cracked. Why? Because if you are a designer, you will be knowing that there will be impact. So what is the load which is considered there? Impact load. So the impact load due to what? Impact load due to rails. So when you are designing even a platform, you should consider that rail load. And the other thing is the place where you will be having a mining area. If you are constructing a cement factory, the cement factory will be constructed only in the slope of the hills where you have the raw materials, yes or no? You will be having a limestone in particular hill or a mountain, there you will be having the cement factory. You will be extracting the limestone by blasting, yes or no? Without blasting you cannot get the limestone. When you are constructing a cement factory, you should take care that the impact due to the blast is being considered when your structure is being built. When you are constructing a structure in your college premises, that is at Rajarajeshwari Engineering College, you don't need to construct the two loads. What are they? Rail loads is not occurring here, and another load is what? Blast loading is not occurring here. So you should know that when you are nearing to the railway track and it is at certain meters, you have to consider that accidental load, that is blast or impact. And next thing is collapse due to various possibilities such as exposure to exceeding the load bearing capacity, overturning, sliding, buckling and fatigue fracture should be prevented. Before the collapse, these are the stability aspect which has to be taken care. This point is bearing capacity, overturning, sliding, buckling and fracture. So these components comes under the safety. So this is a research topic. What is that? Progressive failure. What do you mean by that is, your college building have number of bays. That is, you have around 50 column here. If one column is being settled at one point, take an example, it might be due to over settlement. Your whole structure should not collapse. Only the last column should collapse and the rest of the building should be safe. This concept is known as progressive collapse. As a structural designer, you should design that if one member is being failed, your total structure should not fail. That the single member only has to fail. So this is a mode of designing. Next thing is serviceability. Serviceability issues related to utility of a structure should perform satisfactorily under the service load. Okay, what are the service factor is excessive deflection. In your safety aspect, it should not collapse, it should not slide, tilting, partial destruction or full destruction is not allowed. But in case of serviceability, excessive deflection itself is not allowed. Cracking, vibration, durability, these aspects are not allowed. See, certain structure might be looking safer. In certain bridges, you have observed that when you are traveling in a bridge, the bridge might be giving a vibration. When you are traveling in a, it might be water bridge or it might be a land bridge. When you are crossing in the bridge, you might observe certain level of vibration. The structural engineers will observe that vibration, that the vibration will be within the limit and within the human comfort. If it is going beyond that, then your structure has to be redesigned or reconstructed. The same way, if you are using a car, if the car is having more than 15 or 20 years, your car will be observing more number of vibration. When you are driving a old car, you will be having high vibration. When you are driving a new car, it will be having less number of vibration. Why? Because the components will get wear and tear, so that when it is rotating, it will be having higher vibration. The same way, in civil engineering aspect also, if your structure is being built, if your bridge is being built, when the vehicle is passing, the vibration should be within the limit so that the serviceability issue is not addressed. That is the part of vibration. When cracking, if you are taking the cracks into consideration, cracks are structural cracks and non-structural cracks. See, certain cracks can be healed by painting itself. If you are making the second coat or third coat of the paint, it could be filled by only the paint. But certain cracks, even though if you are making any painting, it will not go. You have to do plastering. That is non-structural cracks. Certain things are environmental cracks. This might be due to alternative heat and cold. Certain cracks are non-structural cracks. If you are placing a mortar again, it might be fixed. But the third level of cracking is structural cracks. If you are making a plastering also, the cracks will be visible. In that aspect, you have to reconstruct your structure. That is the third level of cracking. So these issues comes under serviceability. Impermeability. If you are constructing a water tank, the water tank should be impermeable. You can observe that in certain house, the rainwater slowly dampens your building. But when you are constructing a water tank, can you accept those kind of dampness? Can you allow your water to pass through your walls? No, you cannot accept. In those areas, impermeability is very much required. And when you are building a theatre, acoustic property has to be taken care. You should be making sure that the sound will not go beyond your hall. That is the cinema hall. Beyond the cinema hall, your sound should not go. In those areas, you will be taking care of the acoustics, thermal insulation. So these criteria will come under serviceability. What are they? Deflection, cracking, vibration, acoustic, impermeability, then thermal insulation. These much of concept you will be taking. When designing, it is not only the part giving the dimensions and the material. You should check for all the criteria. Whenever you are designing, you will be doing check for shear. Yes or no? You will be doing check for deflection. Likewise, you have to do check for vibration, check for cracking, check for acoustics, like that. If you are building those kind of structure, since you are a student, you will be not going through these aspects. But when you become a designer, and if you go through your career after 30 or 35 years, you will be getting all the clients regarding this aspect also. But when you are going to those areas, you have to consider all the aspects. When you design your structure, make sure that your sizes and dimensions are optimum. You have selected the right material and you have done the check for all the things. Check for impermeability, everything you have to do. Okay, what are the other factors? You take it down. These are all the long-term factors. While selecting a material from a structure, designer has to consider the long-term environmental effect, which include maintenance, repair and retrofit, recyclability. Why they are preferring steel structure is, steel structure have the component of recyclability. What do you mean by that? If you are building an industry and all the members are constructed by using steel, one day you are making your industry at different location. What you can do is, you can uninstall, that is you can remove all your bolt, nuts can be removed, and you can take the same material and you can build your structure in another area. If you are going for naturals, a natural is a parlor, but if you visit each and every parlor, you will be having same kind of the interior work. Even the color will be same, even the way they provide the mirror will be same, all the concept will be same. So likewise, if you are visiting a McDonald's, you can see that you will be having the serving area, cooking area and the visitor area, everything will be same. So if McDonald's is changing their service outlet somewhere, they will just uninstall all the components and they will reinstall in another location. As simple as that. You should note that when you are designing a structure, you should check the recyclability. When you are using a material, that material should be recyclable. You can use it another time. What is the disadvantage of concrete? Can you recycle another time? If you construct once, you have to demolish, it becomes a waste. That is the disadvantage of concrete. But the advantage of steel structure is you can recycle. If you are buying steel for 70 rupees, you can dismantle, even though you are not using, you can resell. The weight and cost of steel will be same, yes or no? If you are purchasing for 70 rupees, you can sell it for 65 rupees. You will be getting the same profit, yes or no? But can you construct the concrete material, concrete wall, you will be building for around 4,500 per meter cube. Can you give the same concrete for same price or for 10%? No, they will not even buy. You have to pay the amount for dismantling and disposing. That is the other factor. You have to check that you have recyclability or not. Environmental effect of the demolished structure, adaptability of fast construction, demountability and dismantling of structure for future date. So, not only a designer is thinking for safety, he is thinking for serviceability, and the other factors are how to recycle your waste, what material you choose. That is what I have given you an example called the 3 bricks: hollow block, fly ash and red brick. So designer selects which material to use for my construction. So while selecting your material, you should select that it is environmental friendly, and after the lifetime also that structure should be capable of recycling. Okay, with this I conclude this today's class. If you have any doubt, so today I want to give an outline. Not the designer or structural engineer is not only a person who is taking the analysis and designing. He should know all the aspect that how a structure should build,